Hi friends, welcome to second lecture of class 10 science chapter 13 magnetic effects of electric current. In the first video we have seen that an electric current through a metallic conductor produces a magnetic field around it. In this video we shall discuss this further and also try to find the direction of a magnetic field. So we shall study three cases of magnetic field due to a current carrying conductor. The case 1 will be a magnetic field due to a straight conductor. The second case will be magnetic field due to a circular loop or circular coil. And the case 3 will be about magnetic field due to a solenoid. Let's study with the first case, that is magnetic field due to a current carrying straight conductor or straight wire. So let's do an activity to understand this. We take a straight copper wire named XY and insert a cardboard in its center. Put few iron fillings on the cardboard. When current is passed through the XY wire, we observe that the iron fillings arrange themselves in concentric circle pattern. So this indicates that a current carrying conductor or wire produces magnetic field around it. But can we find the direction of these field lines? Yes, this can be done by the right hand thumb rule, also known as Maxwell's corkscrew rule. So this rule is a convenient way to find the direction of magnetic field. Now, how is this rule applied? So consider that this is a current carrying wire. To apply the right hand thumb rule, place your right hand's thumb in the direction of the current flowing in the wire. So consider that current is flowing in the upward direction. So here I have placed my right hand's thumb in the upward direction, which is the direction of the current. Now wrap your fingers around the conductor. So here I am wrapping my fingers around the conductor like this. So the direction of the wrapping of fingers indicates the direction of magnetic field lines. So this means that magnetic field lines will be formed in this direction, like this. So this means that magnetic field lines will be formed in the anti-clockwise direction. So basically, take your thumb in the direction, right hand's thumb in the direction of current. Wrap your fingers around the conductor. The wrapping of fingers will indicate the direction of magnetic field. Thus, if the current flows upwards, the field lines will be anti-clockwise. Now, let's take another example. In this example, the current is flowing in the opposite direction, which means the current is flowing downwards. So, therefore, I will take my right hand's thumb in the downward direction. And then when I wrap my fingers, when I curl my fingers around the conductor, then you can see that the direction is like this. So the direction is clockwise. Therefore, when current flows downwards, the field lines will be formed clockwise. So I hope that with the help of these examples, you are clear with the application of right hand thumb rule. Now, I am giving you a question to try it yourself. Now, let's discuss the properties of magnetic field due to a straight conductor. First, magnetic field is directly proportional to current. When current through the wire increases, magnitude of magnetic field also increases. Second, magnetic field is inversely proportional to distance. The magnetic field decreases as the distance from the wire increases. For example, further we take the compass from the wire, the lesser is its deflection. Now, let's discuss the second case, which is magnetic field due to a circular coil or circular loop. So, insert a circular coil in a cardboard. Put iron fillings on the cardboard. On passing current, following pattern is observed. So, at each point of the coil, concentric circles will be formed, as you can see in this diagram. But at the center, we observe a straight line. This is because at the center, the concentric circles would become so large that a small arc would appear like a straight line. So if we take a very small part of a large circle, then it appears to us like a straight line. But in reality, it is nothing but a concentric circle if we complete it. Third, if there is a circular coil having n turns, then the magnetic field produced is n times as large as that produced by a single turn. For example, if we have 5 turns, then the magnetic field produced will be 5 times to that of 1 turn. Now let's discuss the third case, which is magnetic field due to a solenoid. So what is a solenoid? A coil having many circular turns of insulated copper wire wrapped in the shape of a cylinder is called solenoid. On passing current, a solenoid behaves like a bar magnet. One end of the solenoid behaves as the magnetic north pole, while the other end behaves like a south pole. The field lines inside the solenoid are in the form of parallel straight lines. That is, the field is uniform inside solenoid. So, solenoid is quite similar to a bar magnet. The strength of magnetic field produced in solenoid depends on current and the number of turns of wire. Now, let's see the use of solenoid. So, solenoid is used for making electromagnets. A magnetic field produced inside the solenoid can be used to magnetize a piece of soft iron when placed inside the coil of solenoid. So, electromagnet is a temporary magnet and it is used for lifting heavy scrap metal in scrapyards. It also has many other uses, and you can comment in the comment box to tell me about the other practical uses of solenoid. So in this lecture, we learnt about different cases of magnetic field produced in a current carrying conductor. This was all about this lecture. Thank you.